Property of an angle bisector of a triangle theorem. Let's learn. Theorem. The bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. Given. In triangle ABC, bisector of angle C intersects segment AB in the point E. To prove, AE upon EB is equal to CA upon CB. Construction. Draw a line parallel to ray CE, passing through the point B. Extend AC so as to intersect it at point D. Proof. Ray CE is parallel to ray BD and AD is transversal. Therefore, angle ACE is equal to angle CDB because these are corresponding angles. Let us mark it as statement 1. Now, taking BC as transversal, angle ECB is congruent to angle CBD because these are alternate angles. Let us mark it as statement 2. But angle ACE is congruent to angle ECB because it is given. Let us mark it as statement 3. Therefore, angle CBD is congruent to angle CDB from statements 1, 2 and 3. In triangle CBD, side CB is congruent to side CD because sides opposite to congruent angles are congruent. Therefore, CB is equal to CD. Let us mark it as statement 4. Now, in triangle ABD, segment EC is parallel to segment BD by construction. Therefore, AE upon EB is equal to AC upon CD by basic proportionality theorem. Let us mark it as statement 5. Therefore, AE upon EB is equal to AC upon CB from statements 4 and 5. For more information, write another proof of the theorem yourself. Draw DM is perpendicular to AB and DN is perpendicular to AC. Use the following properties and write the proof. 1. The areas of two triangles of equal heights are proportional to their bases. 2. Every point on the bisector of an angle is equidistant from the sides of the angle. Converse of angle bisector theorem. If in triangle ABC, point D on side BC is such that AB upon AC is equal to BD upon DC, then ray AD bisects angle BAC. Property of three parallel lines and their transversals. Activity. Draw three parallel lines. Label them as L, M, N. Draw transversals T1 and T2. AB and BC are intercepts on transversal T1. PQ and QR are intercepts on transversal T2. Find ratios AB upon BC and PQ upon QR. You will find that they are almost equal. Theorem. The ratio of the intercepts made on a transversal by three parallel lines is equal to the ratio of the corresponding intercepts made on any other transversal by the same parallel lines. Given line L is parallel to line M is parallel to line N. T1 and T2 are transversals. Transversal T1 intersects the lines in points A, B, C. T2 intersects the lines in points P, Q, R. To prove AB upon BC is equal to PQ upon QR. Proof. Draw segment PC which intersects line M at point D. In triangle ACP, BD is parallel to AP. Therefore, AB upon BC is equal to PD upon DC by basic proportionality theorem. Let us mark it as statement 1. In triangle CPR, DQ is parallel to CR. Therefore, PD upon DC is equal to PQ upon QR by basic proportionality theorem. Let us mark it as statement 2. Therefore, AB upon BC is equal to PD upon DC, which is equal to PQ upon QR. From statements 1 and 2. Therefore, AB upon BC is equal to PQ upon QR. Remember this. 1. Basic proportionality theorem. In triangle ABC, if segment PQ is parallel to segment AC, then AP upon PB is equal to QC upon BQ. 2. Converse of basic proportionality theorem. In triangle PQR, if PS upon SQ is equal to PT upon TR, then segment ST is parallel to segment QR. 3. Theorem of bisector of an angle of a triangle. If in triangle ABC, BD is the bisector of angle ABC, then AB upon BC is equal to AD upon DC. 4. Property of three parallel lines and their transversals. If line AX is parallel to line BY, which is parallel to line CZ, and line L and line M are their transversals, then AB upon BC is equal to XY upon YZ. Now let's see some solved examples. Example 1. In triangle ABC, DE is parallel to BC. If DB is equal to 5.4 centimeters, AD is equal to 1.8 centimeters, EC is equal to 7.2 centimeters, then find AE. Solution. In triangle ABC, DE is parallel to BC. Therefore, AD upon DB is equal to AE upon EC by basic proportionality theorem. Therefore, 1.8 upon 5.4 is equal to AE upon 7.2. Therefore, AE into 5.4 is equal to 1.8 into 7.2. Therefore, AE is equal to 1.8 into 7.2 upon 5.4, which is equal to 2.4. AE is equal to 2.4 centimeters. Example 2. In triangle PQR, segment RS bisects angle R. If PR is equal to 15, RQ is equal to 20, PS is equal to 12, then find SQ. Solution. In triangle PRQ, segment RS bisects angle R. PR upon RQ is equal to PS upon SQ by property of angle bisector. 15 upon 20 is equal to 12 upon SQ. SQ is equal to 12 into 20 upon 15, which is equal to 16. Therefore, SQ is equal to 16. Now let's see the activity. Activity. In figure, AB is parallel to CD, which is parallel to EF. If AC is equal to 5.4, CE is equal to 9, BD is equal to 7.5, then find DF. Solution. AB is parallel to CD, which is parallel to EF. AC upon CE is equal to BD upon DF by property of three parallel lines. 5.4 upon 9 is equal to 7.5 upon DF. Hence, DF is equal to 12.5. Activity. In triangle ABC, ray BD bisects angle ABC. A, D, C are collinear. Side DE is parallel to side BC. Points A, E, B are collinear. Then prove that AB upon BC is equal to AE upon EB. Proof. In triangle ABC, ray BD bisects angle B. Therefore, AB upon BC is equal to AD upon DC by angle bisector theorem. Let us mark it as statement 1. In triangle ABC, DE is parallel to BC. AE upon EB is equal to AD upon DC by basic proportionality theorem. Let us mark it as statement 2. AB upon BC is equal to AE upon EB from statements 1 and 2. Now let's solve practice set 1.2. Question number 1. Given below are some triangles and lengths of line segments. Identify in which figures ray PM is the bisector of angle QPR. Answer. 1. Ray PM is the bisector of angle QPR. 2. Ray PM is not the bisector of angle QPR. 3. Ray PM is the bisector of angle QPR. Question number 4. Measures of some angles in the figure are given. Prove that AP upon PB is equal to AQ upon QC. Solution. Proof. In triangle ABC, line PQ is parallel to line BC, and angle P is equal to 60 degree and angle B is equal to 60 degree. Hence, angle P is congruent to angle B. Hence, AP upon PB is equal to AQ upon QC by basic proportionality theorem. Answer: AB upon PB is equal to AQ upon QC. Question number 7. In figure, if AB is parallel to CD, is parallel to FE, then find X and AE. Solution: AB is parallel to CD, is parallel to FE. Hence, BD upon DF is equal to AC upon CE. By putting the shown values, we get 8 upon 4 is equal to 12 upon X. We have to find the value of X. Hence, X is equal to 12 into 4 upon 8. Hence, X is equal to 48 upon 8. Hence, X is equal to 6. X is equal to CE. Now we have to find AE. AE is equal to AC plus CE. By putting the given values, hence, AE is equal to 12 plus 6. Therefore, AE is equal to 18. Answer: X is equal to 6 and AE is equal to 18. Question number 10. In the figure, X is any point in the interior of a triangle. Point X is joined to vertices of the triangle. Segment PQ is parallel to segment DE. Segment QR is parallel to segment EF. Fill in the blanks to prove that segment PR is parallel to segment DF. Solution: Proof: in triangle XDE, PQ is parallel to DE, given. Hence, XP upon BD is equal to XQ upon QE by basic proportionality theorem. Let us mark it as statement 1. In triangle XEF, QR is parallel to EF, given. Therefore, XQ upon QE is equal to XR upon RF by basic proportionality theorem. Let us mark it as statement 2. Therefore, XP upon PD is equal to XR upon RF from statements 1 and 2. Therefore, segment PR is parallel to segment DF by converse of basic proportionality theorem.